Good evening, friends. My name is Zishan, and I'm going to discuss a topic of theory of machines, which is Coriolis component of acceleration. So, before going into detail of that, first let me give you the brief idea about this concept. Is that let us assume that this is a disk which is rotating along this fixed center O. If this disk is rotating along this fixed center of O, and I'm considering this point A, which is moving along this horizontal path and reaching this point B, we can easily understand that the velocity of this point A and the velocity of this point B will be given by, that means velocity of point A is given by OA into omega, whereas the velocity of B along this vertical direction is given as OB into omega. Notice that velocity, if the object moves back to the point O, the velocity at point O will be 0 along this vertical direction. It is clearly observed that the velocity is going on increasing as we are moving from point O to point A to point B. Although we have not applied any acceleration along this direction, but the acceleration is induced by the nature of the system itself. Hence, this kind of acceleration is called as Coriolis acceleration. We'll go into detail of this Coriolis acceleration. We'll find out the magnitude and the direction. So first let us start with the magnitude. Now we've seen that if the object is moving along this path of OB, it is also experiencing some acceleration in this vertical direction. So the velocities at A and B is given by OA into omega and OB into omega. Now VB minus VA, which is these velocities, will be given by OB into omega minus OA into omega, which is equal to OB minus OA into omega. Now let us multiply with a constant t, which is the time taken by the object to move from point A to point B. VB minus VA into t is equal to OB minus OA into omega into t. This value on the left hand side suggests us that the velocity is multiplied with the time, the velocity at point B minus the velocity at point A into t. This is the velocity at point B and this is the velocity at point A. So the object has traveled a distance of d from point A while coming from point A to point B. So we can directly write that d is equal to OB minus OA into omega into t. This is the point D. This is the, you can write that as the point A, and this is the point B, and here you have velocity of A, here you have velocity of B, and this is the distance covered, d. Now let us assume that an object has started with 0 initial velocity and has achieved some velocity like v at this point and has covered the distance d. So this distance is given by t is equal to ut plus half at square, where u is equal to 0. That means this complete value becomes 0. That means d is equal to half at square. So by combining these two equations, we get half AT square is equal to OB minus OA into omega t, where this 1t from here and t will get cancelled, and A can be given as OB minus OA upon t into 2 omega. Now here, just understand this OB minus OA upon t. What is OB minus OA upon t? OB minus OA upon t. OB minus OA upon t can be directly written as AB upon t into 2 omega. Now if we consider that the object A, the object was moving from point A to B with a fixed velocity v, so that velocity is given by the distance traveled upon the time taken. Now the time taken for the object to reach from point A to B is t, and the distance traveled is AB. Hence the velocity can be directly written as A is equal to 2v omega. And this is the final equation for finding out the magnitude of Coriolis component of acceleration. Now friends, let us go find out the direction of Coriolis component of acceleration. It's very simple. If you consider a system in which there are 1, this is 2, and there is one more link, a slider 3. Let's assume that the link 2 is rotating in a clockwise direction with constant angular velocity omega. Let us say that this is the point C, this is the point A, and here you have a point B. Now at point A, if we have to calculate the velocity in perpendicular direction, which can be given as OA into omega, whereas at the point C it is given as OB into omega, and at C it is given as OC into omega. Now here it's very much clear that the velocity at point B is higher than the point C and from point A as well. Now if the slider moves up, its velocity is increasing. That means the object is accelerating. It's accelerating along the direction of velocity. That means it is accelerating in this direction. That means if the slider is rotating clockwise and the slider is moving, if the link 2 is rotating clockwise and the slider is moving in upward direction, then the Coriolis component will be in the right side direction. If the slider is moving downwards, the Coriolis component of acceleration will be in the backward direction. Similarly, in the other case, if this is the link 2 and this is the slider link 3 and this is link 1, O point, again A and B, and this is the C point. If the link 2 is moving in counterclockwise direction with a constant angular velocity omega, we can easily understand that if the slider is moving up, the velocity is increasing in this direction, hence the Coriolis component of acceleration will be in this direction. Whereas if the slider is moving downwards, the Coriolis component of acceleration will be in this direction. So this is how you can get the direction as well as the magnitude of Coriolis component of acceleration. Thank you guys. Let's meet you in the another lecture.